want to challenge you further. What if you be asked to write electronic configuration? Okay, this is barium. So it's electronic. So this is barium. Barium contains 56 electrons. So here we write the electronic configurations of barium. So what if we'll be given maybe orgasium, organism element. For example, write the electronic configuration of organism, which it contains 118 electrons. So you will have a long electronic configuration. You eliminate but you will have a very long electronic sequence or configuration. So the chemists, or the chemists, we are not satisfied on writing the electronic configurations of elements by using this approach because it used to be long. So I have exposed the challenge there. Then now allow me to teach you electronic configurations of the noble gases. So you say that, if example this one, so you say the electronic configurations of OG is very long. So very long and dirty and confusing. So you say that in order to solve that problems, right, to reduce or to shorten the length of what? Length of the electronic configuration, advanced electronic configuration. Okay, in order to reduce the length of the electronic configuration, then noble gases may be used. So these noble gases that we are saying about, we say that, for instance, you see here, in case of manganese, here you have 2 plus 2 plus 6, it is what? 10 plus 6, 2 plus 2, this is 18. So 18 representing argon. So instead of writing these electron configurations of 1s up to 4s, we just replace this sequence of 40 of sublevels from 1s square to 4s square by what? No, to 3p. So it means that we can replace, because 2 plus 2 it is 4 plus 6 it is 10 plus 2 it is 12 plus 6 it is 18. So we may replace this sequence by a noble gas called argon. Similarly to zinc. Here we have 2 plus 2 plus 6 is equal to 10. Plus 2 it is 12. Plus 6 it is what? 18. Then it continues. So it means that instead of writing these 5 sublevels, that 1SC, 2SC, 2P, 3SC, and 3P, we can replace that sequence with the noble gas, which is argon. That's what now am I going to teach you, because it's a very important subject. So here we say that electronic configurations of the noble gases, like that one's used to shorten the configuration. So we say that in use of 40, use of noble gases to shorten what? The electronic configuration, or to shorten electronic configuration. This is the subtitle. How can you use noble gases to shorten? To shorten what? The normal the advanced electronic configuration. So as I said, now let's just repeat again. The noble gases are used in electronic configuration or in writing or drawing. Drawing what? The electronic configuration okay, in writing or drawing the electronic configuration of elements. So used in writing the electronic configurations of elements to shorten it. Okay? So I would like to teach you, we say that in chemistry there are 80 noble gases. So in modern periodic table there are 8 known. There are 8 known noble gases. Known noble gases. So let me teach you each noble gas and how do you use it to write electronic configuration. Very interesting part. You enjoy chemistry? The first noble gas is helium. Say helium. So this one, the symbol is this. So this is used to shorten electron configurations of the first 2 electrons for an atom which atomic number is atoms. So you say that helium, say helium, is used to shorten, okay, to shorten an electronic configuration, an electronic configuration of the first 2 electrons. First 2 electrons. First 2 electrons for an atom with atomic number of atomic number of 2 but greater than 2 but less than 10. Why this is limited like that with atomic number? Because it says it's atomic number of an atom is atomic number or less than this one. Why do you say like this? There's a reason. We say that helium is used to shorten electron configuration of the element with atomic number greater than 2, less than what, but less than 10. Why? Because simply say that the number of electrons in helium is 2, the number of electrons in argon is in neon, let's say, or in argon it is what? Let me start what? Neon. So neon is what? It is 10. And then go for argon, it is what? It is 18. Etc. etc. Right? So if you find the difference between this noble gas and this one is what? Is between these two values. So helium can be used to write the electronic configurations and show the electronic configurations of the element between helium and the neon. Right? Again, you see that what the difference between this noble gas and this one is 8. Right? So that 8, it means that 8, this neon, it can be used to write electronic configuration. It can be used to shorten the electronic configuration between 10 and the 18. It should not exceed 18. Why? Because when the value of neons will be equal to 18, then you find another element which is called argon. Are we together? Okay. So for example, just to give you examples for this 20, we say that, for example, you want range electron configurations of 40 of carbon, right? Of carbon. So to write electron configurations of carbon, I told you that we used to say that 1s, 2s, and then 3s. 3s not 2p. Right? So this is, we have 4 electrons, we have 2 electrons. So that electron configurations of 40 of carbon with 6 electrons. So by using helium, now you can say that the new electron configuration, which is useful of carbon, it means that because you have this one S, so here we say that you have what? A noble gas. So this is helium, right? So helium, and then heliums, it occupies what? 1s, the next it is 2s square, then 2p square. Right? So I have replaced this by helium and the print. Okay. That's the first noble gas. The second noble gas, we call it what? Neon. Say neon. So neon is what? Neon. So we say that it's used to shorten electron configurations of the first 2 electrons if one atom atomic number greater than that. So what does it mean? So again, for neon, we say that that is used to shorten electronic configurations of the, we say that neon, just let me read. Neon is used to shorten electronic configurations of the first 10 electrons for an atom with atomic number of greater than 10. So neon is used between atomic number is just to what? Just between what atomic number? Okay? Atomic number greater than what? Greater than 10, but less than 18. So for example, also teaches through examples, make the concept become easy. So for example, maybe asked that write electronic configurations of aluminum. So this one usual, we write 1s, then the next sub-level is 2p what? 6 electrons, no. Yes, 6 electrons. So total will be 10. So remain what? 3. 3, the next energy level, 3s. 3 what? S. So 3s accumulate 2 electrons. Right? Then next after 3s we have 40, 3p. So 3p, because these are 11 electrons and aluminum contains 13 electrons. So 2 electrons will be here. Right? But examine 2 plus 2, 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 2, it is what? 2 plus 2 plus 6 plus 2 plus 2 is equal to 14. So this is 1 electron. But if you examine this electronic configuration, you find that 2 plus 2 plus 6 is equal to 30 now. So it means that you can place this sequence from here to there, and then say that the electronic configurations of aluminium, it will be equal to what? It will be equal to the electronic configurations of neon, and then the remaining sub-energy level is 3s squared, then 3p power. Right? So that the concepts of what of neon. Number 3, we have argon. Say argon. So you say that the argon is used between the atomic number. So you say that argon is used between the atomic number from atomic number greater than 18 greater than 18 but less than what? So the 6. 18 to 36. So it means that argon, the range of argon will be this. That's from what? From 18 to the 6. So 18 to 36. So for instance, we wrote the electronic configuration of zinc. What the number for electrons in zinc? Zinc. So zinc, I told you that contains 30 electrons. So in right electron configuration, 1s, 2s, 2p, and then 3s, then 4p, so next energy level, three, or 3D. This is it. Yeah, 3D. 3s, 4p. Where is 4s first? That's why that I say to omit that contradiction, the sequence is always better. But we wrote it a few minutes ago. So how many electrons? 10 plus 2, 12. And then 3p. Total, how many are they? So there you have 10, 18. Next, you have 4s. So 4s. You should not claim, you have just to do the half bar sequence and then you get. So that is 20. Then next you have what? 3d. Right? So 3d, so these are 20, 30 minus 20, it is 10. So this getting 10 electrons. Right? But look, 2 plus 2 plus 6 is equal to what? 10. Right? 10 plus 2, 12. 10 plus 12 plus 6 is equal to 18. 18 is what? 18 is a atomic number of which element? Argon. So instead of writing the long electron configuration like that, we can just write the shortest like this. That here we have what? Argon element, and then this is the valence shell that we have 4s, and then 3d is 10 electrons. That's the point I was making for. So let us go for other elements. The next element is number 4. This we call the krypton. Say krypton. Say krypton. So this is, it has an notation of Kr. It's new, possibly don't know, don't worry. It's not, we are not learning about the normal gases here, we are learning just how we can write. So this one is used to shorten the electron configurations of the first 54 electrons for an atom with the atomic number of greater than 54 but less than 86. So the range of krypton is equal to what? From greater than 36 between 36 and what? 54. So that the range for what? For krypton. The symbol of krypton is this. Then we go for number 5. So in some case scenarios, when you find that the atomic number is greater than this, then you have to think about what? Krypton. Then you come what? The next one we call it hexagon. Hexagon. And this, the symbol for hexagon is XE. So the range of hexagon (54 to 86). Next one is called radon. Radon. So from 50. Radon, we say that is shortened that 86 here, and that ends with 60, therefore the next. So radon is Rn. It's used to shorten that ones. But this is used in first 86 electrons for an atom's atomic number of greater than 86. Greater than 86. So the range for this one, this is used to write electron configurations for elements that have atomic or number of electrons greater than 86. So the way that we write for radon is just like this one. However, that is questions are rare to use this. So now to summarize, we say that we can write electron configuration by using helium. We can write electron configuration by using what? Neon. We can also write electron configuration by using argon. We can write electron configuration by using what? Krypton. We can write electron configuration by using what? Hexagon. Then we have what? Hexagon, krypton, then we have radon. Right? So this is the summary of 60 noble gases that are used to write electron configuration. So from now onwards, you have to use these noble gases. So for instance, so let us go. So for example, this is the example 5, example 05. Okay? Right? The electronic configuration electronic configuration of R, iron, iron, and then the other one, the other element is scandium. Yes. Then C, one just to show is gallium. Gallium. This is 31. So write electronic configurations of the iron, Roman R, scandium, and what? Gallium. But the atomic mass of gallium, which is written like this one, is what? 1. Right? So for example, listen. So solution. Also for gallium, then this will be your homework. And this will be your homework. Right? So it starts with gallium. Gallium has total of 31 electrons, right? According to the sequence that I've told you, we said for the elements of 31 will be guided by which? No guess? 31. It will be used by what? Argon. Right? So argon. So for instance, that if you be looking for so you say that the electronic configurations of gallium is equal to, right? Is equal to what? Is equal to argon first, then remain what? So these are 18. 31 minus 18. 31 minus 18 means 10. So 31 minus 18. The answer is what? 13. So if 13, you have to know also, after argon, what is the next orbital? So the next orbital, you have to 5 and what you've been writing. The next orbital, because you have written here, the next orbital is what? 4 SE, 5 UT, add the question. Let me repeat. This has 31 electrons. We have already strength 18 electrons. 31 minus 18 is equal to 31 minus 18. 11 what? 3. Then twice. Right? And twice 1. So next, how do you write this? So refer the alpha principle, and then you know how you write for that case. What will be the next after argon? What will be the next energy level after argon? But according to the documentation after argon, the next orbital is 4s. So you have 4s, you fill some 2 electrons, etc. Okay? So you find that what point am I trying to make? From now onwards, when you be asked to write electron configuration, make sure that you use the noble gases at the point. So if you be asked now to write electron configuration by using orbital method, by using what? Orbital method, then this is the answer. Therefore, yes, whatever you continue about the other energy levels. Okay, so if that's the case, I would like just to say that this is the end of these sessions. Keep on enjoying on writing electron configurations of the different elements. Don't hesitate yourself. In case you have a question, ask me in the comment section. Thank God that you have been